In these PowerPoints, we're going to look at a few types of reactions, 4 common types of reactions, and what you're going to do is recognize the pattern and then be able to describe a reaction as belonging to one of these types of patterns. What you have to pay attention to is recognizing changes in the carbon structure or the numbers of hydrogens from skeletal structures. And so at first it might seem really easy because this is the slides are showing you all the carbons and hydrogens, but you're going to be expected to recognize those patterns when they're not all written there. So let's go through the examples and then we'll practice some problems. Okay, the first reaction is an addition reaction. And in an addition reaction, one molecule adds to the other. So if you look at, hold on, let's get a pointer. If you look at these two molecules, you can see 2 carbons, 2 carbons. There was a double bond, but now the double bond is taken away and a hydrogen added to one side and the bromine added to the other, and it breaks this bond. If you want to simplify this a great deal, what you can do is take this molecule and write it above this one, and then erase the bond between the hydrogen and the bromine, erase one of the bonds in the double bond, and then draw a line from the hydrogen down to the carbon, boom, right here, and then from the bromine down to the carbon, boom, right here. So there used to be a bond here, and there used to be a bond here, and now there's a bond here and a bond here. Notice you lost 2 bonds and you gained 2 bonds, which really makes a lot of sense because there's 2 electrons in every bond, and those electrons cannot evaporate, and they cannot come in from anywhere else unless you have charge coming in. So if the molecules are neutral beforehand, neutral afterwards, so the number of bonds better stay the same. All right, so this is what we call an addition reaction. Here's something called an elimination reaction. It's basically the reverse of an addition reaction. Notice, what do we have beforehand? 2 carbons, 2 carbons. But to these 2 carbons, you have a hydrogen and a hydroxyl. Over here, now there's a double bond, and those 2 things have been taken off as water. And again, we can look at it this way. These 2 bonds go away, and a bond here forms, and a bond here forms. Notice here is that second bond that formed when the first 2 bonds broke. And where is the other one? Holding the water molecule together. Again, conservation of bonds. And you can see what happened to the carbon. We always focus on the carbon structure. What happened? From the carbon structure, something was eliminated or taken away. If we go to the previous slide, we look at the carbon structure and see something has been added to it. Here, it's been taken away. So this is an elimination reaction. Substitution. Again, focus on the carbon structure. What happened to the carbon structure? Here, the carbon had a hydrogen bound to it. Now, what does it have afterwards? A chlorine bound to it. So basically, the hydrogen was taken away and replaced with the chlorine. We call this a substitution reaction. Basically, something came in and was substituted in place of the hydrogen. Of course, you see there's other things going on. The chlorine became hydrochloric acid or hydrogen chloride. You can see there's something else happening here, but what does an organic chemist do? Is we focus on what's going on with the carbon structure. And so we look at the carbon structure and say, well, on the carbon structure, something was substituted for something else. Okay. Here's a rearrangement reaction. Again, focus on the carbon structure. What do we see beforehand? There is a single chain with a double bond at the very end. So 4 carbons in a chain and a double bond at the very end. What do we see here? A 4-carbon chain, but there's a double bond in the middle now. Basically, the double bond moved from the end to the middle. Are the number of bonds the same? Well, if I look at the number of hydrogens, there's 5, 6, 7, 8, and then this would be 6, 7, 8. So the number of hydrogens is the same. And if you were going to count up the number of carbon bonds, you would find them the same. So the bonds before, the number of bonds before, and the number of bonds afterward are the same. So nothing was added, nothing was taken away, and nothing was substituted, because you don't see any change in atoms, numbers of atoms. What happened here? The bonding arrangement rearranged. So you have an isomer. You go from one isomer to another. And so this is a rearrangement. Again, focus on the carbon structure and see what happened to the carbon structure. So now go ahead and try to classify this reaction and see what reaction occurred. Okay, if I look at this molecule here, you could see there is a hydrogen on each of these carbons because each carbon has 3 written bonds. See, 1 carbon here, 1, 2, 3. So there must be 1 hydrogen out here. What happened? The chlorine came in and replaced that hydrogen, and the hydrogen went off attached to the chlorine. Now, we may not show this part to you, and you probably looked at this part as a hint for what was going on. You really need to look from here to here only and see what happened. And you can see a hydrogen was substituted for chlorine. And so what happened? Substitution. Go ahead and try this reaction. If I look at this reaction, what do I see? There's a carbon, carbon, and a double bond. Notice there's no double bond over here. What did you have attached to this carbon? Hydrogen. What did you have attached to this carbon? A hydrogen. Well, of course, there's carbons down here attached also. What do we have afterwards? We still have a carbon and a carbon. The double bond is gone. Is there still a hydrogen here? Yes, there is a hydrogen still attached here because how many bonds do you have? 1, 2, 3. So there must be a hydrogen. How many bonds do I have here? 1, 2, 3. So there must be a hydrogen. The hydrogens did not go away, just the bromines were added. So this is an addition reaction. Try this one and see what happens. Okay, if I look at this reaction, if I look at this carbon and this carbon, I see there's a double bond there. And I can see that's gone here. If I look at this carbon and this carbon, what do I see? There's now a double bond there. Let's look at the total number of atoms here and total number of atoms here and compare to make sure there hasn't been something added or removed. If I look, there are going to be 6 in this ring, 7, 8, 9. So there's 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. Now let's look at the hydrogens. There are 3, 3, that's 6. None, none. 2, 2, 2, 2, 2. So that's going to be 16 electrons. If I go over here and look, I see 3, 6. There's 1 here, none here, 1 here, and then 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 gives you 16. So there's no change in numbers of hydrogens. The only thing that we see is that the bonding arrangement has changed. This is an isomer of this. So what do we call this? A rearrangement. Go ahead and try this reaction. Notice now I'm not giving you any reagents as a hint. Now you have to just look at the carbon structure and figure it out. This is very important that you learn how to do this because in future chapters you will have to do this. So learn to do it now when you're not worrying about reagents at all. Figure out what type of reaction occurred here and then restart the lecture. Okay, first thing you have to do is count carbons. If I look, 1, 2, 3, 4, 5, 6, 7, 8 carbons. 1, 2, 3, 4. Sorry, I don't have a pointer going. Okay, 1, 2, 3, 4, 5, 6, 7, 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8 carbons. So the number of carbons has not changed. Now let's look at the number of hydrogens. There's no heteroatoms, so we don't need to worry about them. Let's just count hydrogens. 1, 2, 3 here. 4, 5, none here. 6, 7, 8, 9, 10. So it's 10 hydrogens here. Number of carbons, same over here. Let's count hydrogens. 1, 2, 3, none here. 4, 5, 6, 7, 8. So if I look at this, you see that we go from C8, H10 to C8, H8. I lost 2 hydrogens when I went from here to here. So what must have happened? Well, somehow 2 hydrogens were taken away. This is called elimination. Okay, now if I look at this reaction, I can see I have a change again. You go ahead and figure out what type of reaction occurred here. All right, let's look. Beforehand, I have 1, 2, 3, 4 carbons. How many do I have here? There's 3, then 4, and 5. So there's an extra carbon there. Well, let's see what else we've got. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. What do I have over here? Well, there's 9. Plus, there's this over here. Can you figure out what was added to this molecule? Okay, if I look at this, I have had 1 hydrogen, an oxygen, and a carbon added to this. And if I really wanted to say what would be the other molecule, I could say it would have to be something with an H, or hydrogen, an oxygen, and then CH3. And that would be exactly right. We actually added something called methanol to this molecule. And this then is an addition reaction. Okay, if I look at this reaction, what do I see here? Figure out what type of reaction occurred and then restart the lecture. Okay, if I look, the carbon structure remains the same. What's changing? We have this alcohol group being replaced with a bromine group. So we're basically substituting the alcohol group for a bromine group. So this is a substitution. Figure out this one and then restart the lecture. If I look, 1, 2, 3, 4 carbons. How many carbons do I have here? 1, 2, 3, 4 carbons. What do I have beforehand? 6, 7, 8 hydrogens. What do I have afterwards? 9, 10 hydrogens plus an oxygen. So if I look, what happened when I went from here to here? It's an addition reaction. Can you figure out what we added? This is an addition reaction, and if you said we added water, then you are correct. Figure out what happened in this reaction. Well, this is basically a reverse of the other reaction. Here we have 10 hydrogens and 1 oxygen. Over here we have 8 hydrogens. So to go from here to here, we had to lose something. We lost water. And so this is an elimination reaction.